indices. So in this video, we are going to look at the fourth law and the fifth law of indices. The fourth law is when you do something to the power of 0, and the fifth law is when you have negative indices. Now, these calculations that we have here all seem to make sense, right? They all have a meaning. 3 squared means 3 times 3, and 5 to the power of 4 means 5 times 5 times 5 times 5, and 7 cubed means 7 times 7 times 7. But what does 4 to the power of 0, or 3 to the power of minus 2, or 7 to the power of minus 3, what does it even mean? Because how can you multiply 4 by itself 0 times? Or how can you multiply 3 by itself minus 2 times? It doesn't really make sense. So what we need to try and do is look at this thing that we have here to spot some patterns to help us to answer these three things that are over here. So I'm going to begin by calculating 4 cubed. I'm going to evaluate 4 cubed. That is 4 times 4 times 4. You can either put that in a calculator, but you should know 4 times 4 times 4 is 64. 4 squared is 16. And 4 to the power of 1 just means 4 being multiplied, just 4, really, nothing it's being multiplied with. So let's see if we can spot what happens as we are moving down this list. Well, as we move down this list, the number in the power is decreasing by 1 each time. 3, 2, 1, 0, minus 1, minus 2, minus 3. And to go from 64 to 16, we are actually dividing by 4. 64 divided by 4 is 16. And to go from 16 to 4, I am dividing by 4 again. So using that logic, if I do 4 divided by 4, I'm going to predict what 4 to the power of 0 is. And 4 to the power of 0, 4 divided by 4 is 1. Let's just check that the calculator is going to show that that's true. Let's do 4 to the power of 0. We do get the answer 1. So I can answer over here, 4 to the power of 0 is 1. Let's extend this by dividing by 4. So I'm going to do 1 divided by 4, 1 divided by 4. You could do 0.25, or you could say that it is a quarter. So I'm going to say it is a quarter, and I'm going to see if that works when I do 4 to the power of minus 1. I do get a quarter, so it does seem to be working. Now I'm going to do a quarter divided by 4. Think what that might be. If not, we can check it on a calculator. So I'm going to do a quarter divided by 4, and I get 1 over 16. So I'm going to leave it as 1 over 16, not as a decimal. And then that means I can answer over in a second. I'm going to divide by 4. 4 to the power of minus 3, well, you can probably spot the pattern. It's going to be 1 over 64. So using this table, this sort of thing that I've got here, I can answer this question. 4 to the power of minus 4 is a quarter. And 4 to the power of minus 2 is 1 over 16. Let's just pull this across so that we've got a bit more space to do some other things. So there's some other ways we could have written this. This one, 16, is 4 squared. And 64 is 4 to the power of 3. So it looks like you take the power, you make it positive and put it in the bottom, and you do 1 divided by that same thing that we've got there. I just want to double check though that this works not just with 4, but that it also works with other ones. So I'm going to just quickly try it with 5. I might not go all the way down, but let's just go down to here. And let's just see what happens when we do the calculations. So 5 cubed, 5 times 5 times 5 is 125. And 5 squared is 5 times 5. Yep, that's divided by 5. 5 to the power of 1 is 5. If I divide that by 5, I do get 5. Oh, look, I'm dividing by 5 each time, and I do get 1. I'm going to divide by 5 again, which is a fifth. And if I divide by 5 again, I would get 1 over 25. Now, 1 over 25 is the same as 1 over 5 squared. So hopefully we're seeing this pattern of things that we've got here. And you can confirm to yourself, 5 to the power of 0, for example, is 1. In fact, anything to the power of 0 is 1. The only thing that's not is if you do 0 to the power of 0, the calculator can't work it out. So that's the only thing. They would never ask you about 0 to the power of 0. And you can ask your teachers, why is 0 to the power of 0? Why does it not exist? So let's try and summarise this. We're going to summarise the two laws that we've just learned. We're going to look at these two on the bottom. So we're going to say that a to the power of 0 is always equal to 1, no matter what it is, unless a is equal to 0, then it's not allowed. So this means things like, I don't know, 8 to the power of 0 is 1, 15 to the power of 0 is 1, it's always going to be equal to 1. Now negatives, let's have a look at the pattern. It seems like when we had these negatives here, when we had 4 to the power of minus 1, we got 1 over 4. 4 to the power of minus 2 was 1 over 4 squared. 4 to the power of minus 3 was 1 over 4 cubed. 5 to the minus 1, 5 to the minus 2. So it looks like what's happening here is we are doing 1 divided by and then making the power positive. So it's going to become 1 divided by a, but we're making the power positive like that. So all of them will be 1 divided by, but you make the power positive. So we can summarize these other ones. We said earlier on that when you multiply with the same base, they must have the same base, you add the powers. When you divide with the same base, you subtract the powers. And when you do a power of a power, you multiply the powers together. So you can either write it as b times c or a to the power of bc like that. So these were our two new rules that we've got here, and in the next video we're going to be doing some examples of different questions. Found this video helpful? Then why not drop it a like and consider subscribing to my channel. If you'd like the next video in the playlist, you can click here to be taken straight to it. And as always, wishing you the very best for all your studies.